In this lesson, we will discuss the law of sines and cosines. The application of this lesson derives from these three listed Common Core standards. To better understand the law of sines and cosines as more than just a random formula, we must understand how and why it is used. We know that typically sine and cosine can be used to find angles and sides of right triangles. However, we can also use the properties of sine and cosine to find the sides of angles of oblique triangles, or in other words, triangles that do not include right angles. It is important to be able to identify the scenarios in which we can appropriately use the law of sines and cosines. The law of sines is to be used in the case of angle side angle, angle angle side, side angle angle, or the ambiguous case of side side angle. The formula for the law of sines works as a ratio. The lowercase letters of the formula represent the side lengths of the triangle, and the uppercase letters represent the angle measurements opposite the side with the corresponding letter. When the given values are substituted into the equation, the problem then becomes a matter of algebra in which you can cross-multiply, simplify, and solve for the variable. The ambiguous case of the law of sines occurs when given a case of side-side angle. Although we will not cover the appropriate measures for solving a side-side angle triangle in this lesson, it is important to understand that for right now this equation cannot be solved as simply as the other cases discussed. Much like the case of the law of sines, there are certain scenarios in which we use the law of cosines. We can use the law of cosines in the case of side-side-side or side-angle-side. Much like the law of sines, the law of cosines is a plug-and-chug equation. Also like the law of sines equation, the lowercase letters represent the side lengths and the uppercase letters represent the angle measurement opposite the side with the corresponding letter. When dealing with the oblique triangle, each side angle pair can be named any letter as long as the letters of the sides reflects the lettered angles. However, once the triangle is labeled, it is imperative that the labels remain for the correct answer to be found. When dealing with the law of sines, you will realize that the method for solving is the same as solving any other ratio equation. However, using the law of cosines can prove to be a little more complex. When solving a side-angle-side triangle, the plan of attack is as follows. Number 1, use the law of cosines to find the side opposite the given angle. 2, use the law of sines to find the angle opposite the shorter of the two given sides, which is always acute. 3, find the third angle by subtraction from 180. When solving a side-side-side triangle, the plan of attack is as follows. 1, use the law of cosines to find the angle opposite the longest side. 2, use the law of sines to find either of the two remaining acute angles. And 3, find the third angle by subtraction. It is important to note that when dealing with the law of sines and faced with the side-side-side triangle, one should check the existence of the triangle. This can be done by checking to see if the sum of any two sides of the triangle are longer than the remaining sides. It is also important to remember to use the correct order of operations whether working with the law of sines or the law of cosines. In this example, you are given b equals 12, c equals 9, and an angle in between the two sides measuring 87 degrees. You are asked to find the side length A. From the given information, it is clear this is a side-angle-side scenario in which we will use the law of cosines to solve. The equation for the law of cosines states that a squared equals b squared plus c squared minus 2 times bc times the cosine of theta a. When we plug the given information into the equation, we get 144 plus 81 minus 2 times 12 times 9 times the cosine of 87 degrees. Through further simplification, the equation then becomes a squared is equal to 225 minus 216 times the cosine of 87 degrees. Finally, To solve the equation, we must take the square root of both sides of the equation, at which point we can use our calculator to approximate the value of our variable. When we do this calculation, we find that the side length A equals approximately 14.6 units. From this equation, we now know that the side length A equals 14.6 units. In this example, you were given A equals 50, C equals 20, and B equals 60. In the problem, you will be required to find theta C. With the given information, you will notice that the scenario is side, 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 in which case we must use the law of cosines to solve for the variable. The equation for the law of cosines states that c squared equals a squared plus b squared minus 2 times ab times the cosine of theta c. When we plug the given values into the equation, we find that we now have 20 squared equals 50 squared plus 60 squared minus 2 times 50 times 60 plus the cosine of theta c. By simplifying the exponents, we find that we have 400 equals 2,500 plus 3,600 minus 6,000 times the cosine of theta c. Through further simplification, we find that we have 400 equals 6,100 minus 6,000 times the cosine of theta c. When we subtract 6,100 for both sides, we find that we get negative 5,700 equals negative 6,000 times the cosine of theta c. Following this step, we must divide each side by negative 5,700, leaving us with the equation cosine c theta is equal to negative 5,700 over negative 6,000, which we can reduce to 57 over 60. Because we are finding theta c, we must use the inverse cosine. Using the calculator to solve for the inverse cosine of 57 over 60, we approximate and get 18.2 degrees. In this example, you are given theta b to be 45 degrees, theta a to be 105 degrees, and side length c to be 2 degrees. From the given measurements, it is clear that the scenario is angle side angle, in which case we must use the law of sines to find the solution. To solve the problem, you must find the remaining measurement, including theta c, side length a, and side length b. We will first start by finding the missing angle measurement. We know that the internal angles of a triangle sum to be 180 degrees. Therefore, we know that the sum of the two given angles plus theta will give us 180. We can set the equation up as a 180 equals 45 plus 105 plus theta and then solve for theta, and we find that theta equals 30 degrees. Now that we have all the possible information we can gather, we can use the formula for the law of sines to find the remaining measurements. The formula says that the sine of any given angle over its opposite side length is proportional to any other angle over its opposite side length. To find the remaining sides and angles, we must fill in as much of the ratios as we can, cross-multiply, and solve for the unknown variables. It is a good idea to start each ratio with what you were given. That way, if you make a mistake, you do not continue to solve the remaining equations with incorrect values. When you've completed the ratios and solved for the side lengths A and B, you should find that the side length A measures approximately 3.86 units and that the side length B equals approximately 2.39 units. Although these equations may seem complex at first, they are patterned. Once you have mastered the pattern, you will find that you are able to solve any oblique triangle problem.